Hello, I'm gonna to introduce the computer evolution today. And what will we learn in this section is like computer technologies or novel applications feasible or computers are everywhere. Okay, I'm I'm first of all I'm going to introduce classes of computers is like personal computers or server computers. Personal computers is what we use in our daily life, but sometimes it's subject to cost, it's subject to performance and trade-off. And server computers based on networks, and it has high capacity, high performance, reliability, but honestly, it's the cost is higher. Okay, the third one is supercomputers, like a type of server, and high-end scientific and engineering calculations. It has the highest capability but represent a small fraction of the overall computer market. And the fourth is the last one is embedded computers. It's hidden as a component of a system, like your washing machine, like your maybe some games. Okay, here is the post PC era. Okay, I'm going to introduce some devices now. For example, like personal mobile device. It's it's operated by a battery. Is connected to the internet. It's hundreds of dollars. It's US dollars. In Taiwan, maybe there are 3,000, 4,000. It depends. It depends on what type is your phone, what functions does your phone have. Mobile devices also represent smartphones, tablets, electric glasses. Okay, what is cloud computing? Warehouse SQL computers, software as a service, or Amazon and Google. And what do we what are we gonna to learn is like how pro how programs translate to machine language. And um, as we know, the computer must execute in machine language, otherwise it cannot execute directly. uh, uh, in other words, it means it need to it need a translator to that computer understand what do I mean. Okay, and there are hardware and software interface, and what determines a program performance, and how can it be proved. But here I need to ask something is like there is no way all performance is better than in two computers. And how hardware designers improve the performance, what is parallel processing. And understanding performance is in some different ways, like algorithms or programming language, compiler architecture, processor and memory system, and basic I/O. It includes operating systems. Okay, algorithm it determines the number of operations executed. Programming language compiler architecture determine the number of machine instructions executed per operation. You may imagine is if there are more instructions, and we need to take more time to instruct this program and process a memory system. There are two type instructions like RISC, CISC. C represents complexity. R represents reduce, and determine how fast instructions are executed. And IO system is like um, determine how fast IO operations are executed. IO is a little bit like interactions with users or what did users see. For example, like a printer is output devices just because they can print out some papers. Let me see. Okay, in next class we will talk about 1.27 great ideas. It's like how what did applications in our daily what what are computers what will computer uses in our daily life. See you. Bye bye.